Thank you, Kyle, and thank you, all of you, for spending your time here with us today. And so, as Kyle said, my name is Dan Flynn. I'm a product security engineer on the consulting engineering team with Apple. And we got a lot to cover here today, so I'm just going to kind of really jump into it real quick. So to begin, I'd really like to echo what Jeremy said during the keynote yesterday. Was that yesterday? I guess it was. It's been a long couple of days, hasn't it? You know what, and we really are really super excited about the momentum that we've seen in enterprise and government in particular institutions. I've been in Apple since 2008, and it really is simply remarkable how far we've really come. Also with the helps of the likes of all of you as well. So we really, thank you for the journey here as well. And so you often hear a lot about how Apple focuses on the user experience, and while that is very much true, in enterprise deployments, I also like to say that it's really about focusing on the productivity of the user. Because if we do something that negatively impacts the productivity of that user, that has a real financial cost associated with it as well. We also believe that when users are involved in the process of the day-to-day usage of their technology, this provides them agency, and it empowers them to be able to achieve their mission goals with as little IT intervention as possible. And so we try to build tools and capabilities so that you can all do that at scale, but also in a defensible manner. And I know it's easy to say that security is important, but really, what does that really mean? It's often sometimes seen as kind of a black art, right? And sometimes the information security professionals, those teams can wield a lot of influence as a result. And so rather than have to seek out some additional security tooling that sometimes can introduce dependencies and complexities, wouldn't it be great if more of this technology could be built in, enabled by default, as well as being effective? And so certain things like robust data at rest protections, data in flight protections, all these things have become table stakes. And customers really want unique biometrics to get access to resources as well. And so let's explore how our devices are built from the ground up with security at the core. And so our goal is really to build products that are secure by default for the vast majority of use cases that are out there in a way that is really transparent to the end user. Because anytime a user has to make a choice about the security posture of their data, they might have the opportunity to make the less secure choice. And so what might we mean by this? And so what you see here on the left is what is often the case, right? Insecure defaults requiring additional work to achieve a minimum bar of security. And so on the right side really is Apple's goal. We want to be able to raise that security bar while limiting the friction introduced to the user. And so we try to achieve this by what is known as shifting left, or considering the security implications at the earliest stages of the development process, even during the design phase. And there's probably no better example of this than our implementation of Touch ID and its privacy guarantees and the rapid rate of adoption by our customers. This is transparent, convenient, and secure. And so we achieve the best security in features like Touch ID and Face ID and now Optic ID through deeply integrating the hardware and the software and the services. And this is something that Apple is in a great position to be able to do. And this integration goes much deeper than just the CPU and the GPU. Apple Silicon systems on a chip, or SoCs, enable hardware acceleration for a variety of use cases. For example, unified memory and on-device machine learning accelerators enable highly performant, energy-efficient, on-device AI workflows that are really kind of unthinkable on the other off-the-shelf computing platforms. Touch ID, Face ID, and Optic ID provide private, secure, and convenient authentication to authorize secure enclave operations, including services such as Apple Pay. File Vault is really best-in-class data at rest protection, available in any off-the-shelf computing environment. And data protection cryptographically separates data from other processes on the system. Secure Boot ensures that the integrity of the operating system and the lowest levels of the boot process are cryptographically validated against the immutable root of trust that is fused into the hardware at the point of manufacture. The signed system volume ensures that the operating system hasn't been tampered with, even if the underlying file system has been changed. System integrity protection protects key areas of the file system and running processes from tampering, even by the root user. The secure enclave performs cryptographic operations and protects secrets, even in the unlikely scenario that the application processor might be compromised. And so, file system data protection is notoriously strong on iPhone and iPad, but I don't think FileVault gets enough credit. And so what I see a lot in the environments and on other platforms is a lot of customers are using like BitLocker in TPM-only mode, and that's done for a user convenience. But what that means is that that device is only encrypted with the hardware key alone. And so if an attacker with a long-lived access to that device, if they're able to install their own operating system and get that device to boot off of it, they might be able to simply copy that data off. And with FileVault, that's simply not the case. Between that and its entangled encryption between the hardware key and the user's passphrase key, as well as the secure boot capabilities that are on there, none of those attacks are practical with FileVault. And so in complex operating systems that are often written in low-level programming languages, memory bugs can be a fact of life. And so attackers can probe the kernel and applications looking for things like buffer overflows and use after free errors in an effort to exploit them and execute their own arbitrary code. And so we've introduced memory integrity enforcement, which is Apple's comprehensive memory safety defense for Apple platforms, making whole classes of these memory bugs impractical to exploit. iOS 15 introduced the kalloc type, a secure memory allocator for the kernel, and its user-level counterpart, xzone malloc, was introduced in iOS 17. The A12 Bionic chip introduced pointer authentication codes, which protect against code flow integrity in the presence of memory corruption. And starting with the iPhone 17 and iPhone Air family of devices, enhanced memory tagging extension is Apple's update to the ARM's memory tagging extension feature that includes additional features such as being enabled by default, always on, and it is synchronous, which means that any of these memory exceptions will not be missed. And so this EMTE is also available to developers in Xcode as well, and all of this is done without affecting performance on the device. But security is a process, right, not a destination. And so Apple feels very strongly that the timely application of software updates should be near or at the top of any security-conscious customer's list. And so we want to make this as simple as possible. But one of the ways to do this is by reducing dependencies wherever possible and taking advantage of as much native built-in functionality. And so when you are developing your security strategy, it's important to know what you are getting already before looking necessarily to supplement with something additional. So know that code signing requirements validate that the software, both Apple and third party, proves that it is indeed from who it says it's from and that it hasn't been tampered with in any way. You may know about XProtect, which terminates the execution of malicious software that's known to Apple. Apple has our own threat intelligence teams that surveys the landscape for malware that's out there. We collect samples, and then we can develop YARA rules that look for patterns of that malware in memory. We make this available to all of our customers on as frequently as a daily basis if needed. And Gatekeeper and notarization defends against unknown software to Apple at all that comes from potentially risky sources. And so if a nefarious developer has any hope of getting execution of their malware at scale, they would have to submit it to Apple, which means they'd probably be unlikely to do because that's a good way of getting caught. And so instead, they'll have to coach users through a series of steps to be able to try to bypass those gatekeeper scrutiny, which, of course, using Jamf, you'll be able to disable the ability for admin users from bypassing these checks as well. Protecting data in flight over networks, even with quantum resistance algorithms, is becoming increasingly important. And remote access to services with network relays has a number of advantages. And so first, relays are highly performant, and they can also operate at the application layer so that the session doesn't require a full network position with an IP lease on the target network. So this narrows the authorization required, providing more granularity, and is really in line with the zero trust networking architecture approach. For VPN, really strongly consider using the native built-in protocols such as IKE v2. Use client certificate identities to authenticate the connection, and use device management, user identity, and device identity as your compliance posture check. If we can do this, then we might be able to eliminate the need for a thick VPN client agent instead. And so Apple devices combine hardware, software, and services that are designed to work together for maximum security as well as transparently for the user. And this is the goal here is to keep both the user's personal and the corporate information safe. It's also important to check that the implementation meets the design goals. And Apple implements a variety of secure design principles from very early on in the design phase through secure coding practices and red teaming exercises as well. And so our Apple security research site makes it easier than ever for researchers to submit reports on the web, get real-time updates from Apple engineering, and really earn recognition for helping to improve security for all of our users. We also partner with security research community, making security research devices available. And so these unique devices have some security capabilities disabled and debugging features enabled so that researchers can test and validate the security posture of iPhone. Built on top of Apple Silicon, private cloud compute for Apple Intelligence is stateless, meaning no user data is stored locally. There are no privileged runtime access processes like remote shells that might be abused by a rogue data center administrator. User prompts are fully anonymized and unable to be targeted, even by Apple. And the architecture is verifiably transparent. And so anyone with a Mac can access a virtual research environment compute node, and the source code has been shared to GitHub. And so we think this transparency really sets a new standard in the industry. And all of this is backed by Apple's Security Bounty Program, which encourages researchers to submit security bugs by rewarding them for their efforts, offering up to $1 million US for the most severe findings. In addition to making devices secure by design, we also ensure compliance with common security standards. And this also begins with Apple's supply chain. And so supply chain security is critical to ensure the integrity of the production of a device. And it's important to validate that it's important to validate that the implementation actually meets the design goals. So I'm going to actually read this part verbatim because this has undergone a lot of scrutiny by our legal department, and I don't want to get it wrong. So manufacturing data is collected at every stage, and it's used to analyze manufacturing metrics, test results, process flow anomalies, and excursions. Device integrity data is moved between module suppliers and final assembly in order to maintain authentication and authorization of components that are used in assembling an iPhone. This prevents unauthorized parts from being used. Data is securely collected and stored at factories and then transmitted to the United States via a highly secure and dedicated VPN connection. Data is stored in Apple data centers across the United States. When a user restores a device to factory settings, it pings Apple secure servers to authenticate that the integrity of the device and key components is maintained. This validates that even after the device leaves the factory, only authorized key encryption components like NFC are present in the iPhone. All device-level tests are retained by Apple systems for 7 years. We also use various inspection techniques in our manufacturing process, like X-ray inspection. We X-ray every single iPhone, iPad, and MacBook to validate that there are no anomalies in any unit. The X-ray has a resolution that measures a diameter less than the width of a human hair. We use machine learning techniques on the optical images we collect in our manufacturing process to look for anomalies in real time. This is also done before we close a unit with automated optical inspection. And Apple regularly engages with third-party organizations to certify and attest to the security of Apple's hardware, software, and services. You can find this on the site that's here, and these certifications are documented in the guide and include things like the FIPS validations and common criteria. Also, Germany's BSI has authorized iPhone for use with classified data in a personally enabled configuration. And so they have determined that the managed apps and data boundary is sufficiently strong to adequately protect classified data in the managed apps and accounts, while still permitting personal apps and accounts the user may wish to use. They have come to this conclusion that this personally enabled model has a superior security posture than, say, a business-only model, which could promote the use of a second device by the user. All right, so everything we've discussed so far, everyone gets for free just by investing in Apple platforms. And so in addition to having systems that are secure by design, but organizations are going to need to deploy and manage these devices at scale and do so in such a defensible manner. And so we want to make sure we're always considering this. And so when designing a security strategy, first, consider everything that we just described that you get built in for free, and then reduce dependencies wherever possible in an effort to prioritize these timely updates. We feel very strongly that keeping your devices up to date is extremely important, and reducing dependencies is one of the ways we can get there. But the saying goes, like, your threat model is not my threat model. And every organization has to classify their data and identify their mission goals and their use cases and their needs to balance that security with productivity. And so you're going to use device management to reduce that attack surface to that which makes sense according to that calculation. And so automating the bootstrapping of a device into management is performed through automated device enrollment. Once that Mac connects to the network, it will be required to enroll in device management going forward. And so therefore, users will be unable to bypass this bringing the device into management. And so last year, we extended this to Apple Vision Pro as well. Managed device attestation ensures that the requesting device, whether it's attempting to enroll into device management or requesting an identity for other purposes, that it is indeed a genuine and specific Apple device and not something just pretending. The device management service, the way this can work, is that the device management service can request an attestation from the requesting device, which it then dynamically fetches from Apple's attestation authority and then returns that to the device management service. Then that service can then cryptographically validate the attestation of certain attributes of the device, such as serial number, UDID, Secure Enclave OS version, and more. And there's a list of a bunch of them. The service can then enroll a client identity on the device to be used for device management with a hardware-bound key, and that creates a very high assurance of that device identity. And all of this is key in a zero-trust networking approach, like never trust, always verify. And as of macOS 15.4, Platform SSO can also now support attestation that identity providers can leverage as well. Once devices are enrolled in device management, institutional policies can be enforced using ensuring compliance. And this is where device management can be used as a posture check for access to those services. Client identities can then be installed for access to services such as native IPv2 VPN, 802.1x using EPTLS, and PKInit for Kerberos as well. Gatekeeper can be configured so that the local admins cannot bypass that notarization check that I mentioned before, and iCloud services can be granularly configured to balance those productivity and security and data sovereignty needs. And then, of course, if a device gets lost or stolen, that device management service can lock or wipe that device remotely. Regulated industries that must comply with very specific security baselines can use the macOS Security Compliance Project that's available on GitHub to automate the auditing of a representative device to see how it meets their compliance needs. Just one note around this, any deviation from a particular baseline does not necessarily mean that this is a vulnerability of any sort. It's more referred to as like a finding. And then therefore, it's up to the organization to determine the impact of that finding, because it might be a perfectly legitimate reason for the business that they need to deviate from that particular baseline. So the project supports a number of baselines, including the NIST 853 group, as well as CN SSI 1253, and DISA's STIG, and several CIS benchmarks as well. All right, so let's take a look at a couple new things we hope you might like. So debuting in iOS 18.4, iPad OS 18.4, and Vision OS 2.4 is the Managed App Framework, along with declarative app configuration. This addresses some of the shortcomings of the legacy Managed App Config that you may have known. And it also adds some additional security guarantees. And so the declarative configuration is supported on all device enrollment types, and developers can implement the Managed App Framework for their apps and most app extensions to automate the configuration of those apps and extensions. And so one of the most significant benefits with Managed App Framework and declarative app configuration is the support for secrets. And so these secrets can support client identities that can be provisioned using your familiar device management methods, such as ACME, SCEP, or PKCS12. And so prior to the Managed App Framework, in order to perform operations with the private key of a client identity that had been provisioned using device management, an app developer would typically use something like AS Web Authentication Session, which would present a limited Safari window. And then the user would be presented with a certificate picker, and if the user chose wisely, then the app would be able to perform encryption or signing operations using that chosen identity. And this would be typically used for things like mutual TLS authentication, right? But now, with Managed App Framework and the declarative app configuration, this eliminates that need for the user to have to select a client identity at all, because instead, this is going to be defined by the device management admin instead. So when you combine this with the client identities provisioned using managed device attestation, this provides extremely strong guarantees that the device is genuine and is indeed the intended device that possesses the client identity, and it hasn't been stolen by an attacker. For all of this to work, app developers will implement the Managed App Framework and define what configurations and secret their apps might consume. They really should then publish the configuration specification so that device management vendors and admins know what configurations to define for their app, as well as any secrets and what they might be used for. And developers should also publish any error code details in case of a configuration syntax or other error for troubleshooting purposes. On the device management side, you would use configurations and secrets identifier usages published by that developer. And device management admins can define these desired values using the app config for apps or the extension configs for the app extensions keys in declarative device management. Populate these keys with the dictionary of values that the app extension understands. And so just some potential use cases, we think, include licensing for apps, VPN extensions, extensible SSO extensions, and apps performing signing and encryption operations. You can all be using asymmetric keys and X509 identities delivered via device management. And so here that you see on the screen is really just some of the ways we think developers might use this framework. And really, there's probably many more that we haven't even discovered yet. And so at this point, I'm going to hand it over to Matt Vlasak, the VP of Product here at Jamf.
Thank you, Dan. All right, so yes, Jamf's mission has always been to help organizations succeed with Apple. That's never changed. But really what that's evolving to is making sure that you can keep those devices secure. As you've seen with everything Dan's talked about, there's a lot of security stuff built into the platform by default. The thing is, how do you light it up and make it work in a way that is suitable for your organization? Exactly like Dan said. They're secure by design devices. How do you keep them secure by design and compatible with your enterprise? So that's our focus, but there's three things I want to start off with talking about how we are extending some of the things that Dan talked about into your ecosystem with Jamf. So first up, OS updates and DDM-based OS updates. So as you heard yesterday in the keynote and some of the keynotes, we have software update settings that allow you to do a lot of the basics. If you haven't looked at blueprints yet where you can configure this, now's your time. You can get those going. You also are able to do a target OS version to say, I want to have this version updated by this on these machines by this date. It allows you to do that using declarative device management. So you push that declaration down on the device device autonomously works out when it needs to do that, optionally providing through those other settings some notifications to help guide the user through that process without relying on third-party tooling. Now, what's new this year was this new really cool set it and forget it OS updates. What's great about this is you are now able, what we do is we will monitor the updates as Apple releases them. There's a feed that Apple provides. We monitor those daily. We find out based upon the major minor patch or RSRs, you can decide and write a policy saying every time Apple releases a new major version, I want these devices in this smart group after X number of days to install that update by this time. Now, it's literally set and forget because we automatically determine all that logic based upon where that device is in the world using local time, based upon its operating systems and those elections you have to make that truly an easy experience. It's something we heard, and as Dan mentioned, making sure you have your operating system patched is the #1 security thing you could do on Apple devices or any platform, and we're trying to make that very easy here. Now, the next thing that we're working on is compliance controls. We're really excited to announce that we've now introduced the Tahoe baselines within our compliance benchmarks tools. So you can just go in there and you will see the new benchmarks that are added as well as modified for Tahoe. We make that really easy just by going into compliance benchmarks within Jamf Pro. I'm really excited to talk about something that we have in beta that you will be able to access here soon. It's called custom declarations. A lot of stuff here because this truly is custom. We're giving you low-level access to do DDM like policy, to experiment and play with the new policies, to do what you need to do, to test them in your environment ahead of anything that we do with Blueprint templates. So you can go in there. We have a tool that we call Declaration Explorer. It's something that our consultant engineering team built. You can get it off of the App Store or through that code. It basically pulls all the YAML from Apple's GitHub service. We provide a listing of all those different declarations. You can go in there and interactively build the JSON using a simple UI interface. So this thing ultimately goes through, and we talked about App Managed. So App Managed is one of those. You can go in there, you can learn about that declaration, how it works, all the different keys, and you ultimately can go through and you can build that JSON code and then be able to directly inject it within a custom blueprint. So you could copy paste that across and put that into a custom configuration within a blueprint editor. You could specify assets and configurations today and at the device or user level and push it down on the device and see what happens. So it's a great way to get familiar with declarations, which is the future of device management on the Apple platform, but also help us understand what workflows you would like to see and give us feedback about how you want to embrace declarations that we may need to explore further. The Blueprints API, we're very excited about that. So we have great developer documentation that's now available. You can go through on there and you can do everything as you saw on the keynote stage through API and also through our new Terraform provider as well that will allow you to go through and start using Terraform for infrastructure as code to go through and automate through a GitOps process a lot of your DDM configurations through Blueprints. So we offer through Terraform today a new compliance benchmark API as a provider. We have Blueprints and then a new device inventory. So device inventory is how we're bringing our platform together to pull data from all of our different components within the Jamf environment. So Pro, Connect, Protect. We can pull all the data together in one request, return it to you, so you could use that in your ecosystem. So if you want to sign up for beta access, account.jamf.com is where you can go in there. There's a beta section. Go ahead and elect for those betas, and you can start playing with some of this stuff. So back to Dan. There you go.
Thanks, Matt. That's great stuff. All right, so once you have a security program that prioritizes software updates, and you've reduced that attack surface on the deployment using device management policy that balances the threat model with the use case and the mission goals of the business, you may want to evaluate any additional potential gaps. And so, but before looking to any kind of third-party solutions in this space, again, make sure you know what you're getting for free. And so as mentioned earlier, XProtect terminates the execution of malware that's known to Apple, and Gatekeeper and Notarization terminate software unknown to Apple that comes from risky sources. But there's also a third category of attack. Sometimes it's sophisticated attackers that sometimes their behavior looks indistinguishable from that of other power user behaviors. And so for this, Apple has made the Endpoint Security Library available. And so the Endpoint Security Library makes it easy for security vendors to register for listening to low-level events of interest and then make a decision of whether to allow or deny that particular event. Endpoint security clients are user space processes that can evaluate and, if necessary, deny kernel-level events without the attack surface implications or the availability implications of operating directly in the kernel themselves. And because of this, it is much easier to develop for. And so even if for some reason an endpoint security client might get wedged because, let's face it, mistakes can be made, our Watchdog D process will kill that endpoint security client and will be respawned while the operating system's uptime remains. Endpoint security debuted in 2019. And thankfully, at this point, many of the major endpoint security vendors that are out there have successfully transitioned their product over to it. And so I'm going to hand it right back to Matt again.
We're going to do this like 2 more times. So as Dan mentioned, the Endpoint Security API is a very important component to the platform ecosystem on the Apple devices. So, I want to talk briefly about macOS telemetry, how that's really important to help making Macs fit into your IT ecosystem, as well as talk about some network relay and managed device attestation components here, and how that fits to complete the security story in a lot of ways on these devices. So as Dan mentioned, on a macOS device, you've got these various APIs with endpoint security, unified logging, network extension. These are all frameworks that Apple provides that are otherwise dormant on the device. But when they're activated by a third-party vendor, you're able to go through and actually get this really rich data that can help security teams better understand what's happening on their Apple devices. Now, as Dan mentioned, there's a lot of, most of the major EDRs and XDRs out there, they have upgraded and they are taking advantage of the native APIs. So they're operating with more stability on higher performance on Apple devices. So the way we see it is if you have CrowdStrike, Defender, SentinelOne, those sort of EDRs, that's great. Because guess what? You're going to help your Apple devices really look good within those consoles on those devices. But what they're doing, those EDRs are doing, is they're taking that signal, they're ingesting those events, they're doing proprietary analysis, they're doing the signal packaging, and they're ultimately sending that out to their back end to be able to elevate broad cross-platform sort of events that are happening not only on the endpoint, but with identity, with cloud workloads, all these different touch points that those security vendors are excellent at. And it's wonderful that Apple devices are being represented in those tools because, again, it helps those devices and the Apple devices be more trusted within the InfoSec teams. But what we've heard time and time again is that there's still some visibility gaps that these tools don't provide because there's select eventing that goes over to a SIEM. So we are able to provide some telemetry streaming that actually will take those same signals but allow you to filter and curate the stuff that your IT organization needs. As Dan said, every team has a different security posture and the position they need. What we find is when we are able to provide a lot of data to those security teams, you can have a really rich view and understanding of the Mac in a way that previously was not possible. So to illustrate this, this is like one of the craziest keynote things ever. We have a timeline that we're able to show where you could have, show that a system booted, that the user logged in at a certain point, that an encrypted USB key was put in, that, hey, we blocked a malicious script. A user elevated to admin. There was a sudo command that happened, a suspicious curl command, very Mac-specific functions that are happening on this device that clearly indicate some sort of compromise. Now, some of the EDRs and XDRs will catch these things, but in some cases they won't. And having a layered security model where your security team can have this raw data from the Mac devices and their fleet at large to be able to develop their own dashboards and their own alerting is something that they love and something that is very, very important for you to be able to provide them, again, because it adds more assurance that these Macs are not a visibility gap within their organization. Now, the other thing is with Private Relay, Dan mentioned it as well. So what's amazing about Private Relay is it is able to work completely agentlessly, and it can coexist with any existing VPN and ZTNA solution you have now. Now, through MD, and this is where we're excited that we're able to take some of the foundations that we have with device management and elevate some outcomes into the network. So using a mobile configuration profile, we could push a relay and an ACME certificate, which uses managed device attestation, to effectively create a secure mask-based tunnel. It uses QUIC and HTTP3 to allow for a really seamless and effectively invisible experience for the end user to protect either SaaS traffic or on-prem traffic from the device and that last mile to our cloud. That's where we do assessment of if the device is managed or not. We can see if it's risky, if it's compliant, and then we can decide to pass that traffic along to a cloud service. So you can egress it out of IP addresses that can fit with allow-less or over an IPsec tunnel to some private workloads you may have in AWS or Google Cloud. But the whole point is the user did nothing. They enrolled the device, and the networking was there as easily as a profile. Like, it just starts working because it's using this managed device attestation behind the scenes. Now, all of those events can be streamed to a SIM and a SOAR, so you could have a full, again, audit log, whether you're on a mobile device or a Mac. You have full view of what that user accessed at what time. And also, you can do some automation with CAPE and SSF to be able to say, hey, we noticed some interesting events on this device. We want to be able to say, have Okta take action against some identity tokens. So we're plugging this infrastructure into your broader IT and security ecosystem. All right, Dan. Back up.
Great, thank you. Okay, so let's pivot a little bit to identity, because credential theft is one of the leading ways attackers get a foothold on the target network, right? And so because of that reason, it's important to move towards an environment that reduces the use of passwords wherever possible. And this is primarily with regards to access to remote resources where an attacker could be anywhere else on the internet. And so using phishing-resistant credentials, such as platform SSO and user secure enclave key mode for transparent authentication to the IDP-packed resources, plus using client certificate identities for access to services like native VPN, 802.1x, Kerberos PKInit, all of this provides passwordless authentication. And so when using security keys or authenticator apps to authenticate the device management enrollment and the registration of platform SSO, you can really implement a full passwordless type of solution. And for this, I think Matt's going to talk. Oh, am I going the wrong way? I went the wrong way. Excuse me. Is there? I hit the lower button. Sorry. It is a really impressive bill. All right, so as I was saying, when using security keys to authenticate device management, registration, as well as platform SSO, you really can implement a full passwordless type of solution. And one note too is realize not every software as a service solution might be federated with an identity provider. There might be some outliers out there. For that, take a strong look at passkeys. They can be a great solution for any non-federated software as a service solutions as well. But before we get into too much around the platform SSO, I did want to highlight just a couple things around managed Apple accounts, which of course provide access to various Apple services, but these accounts are owned and operated by the organization in their identity and access management. And so these obviously could be created manually through Apple Business Manager, Apple School Manager, or automatically if those tools are federated. And this provides the ability for users to access a wide array of iCloud services and other Apple services such as iCloud Drive, Apple Wallet Continuity, iCloud Keychain, and a couple Apple developer services as well. And so this way, IT has management access controls to be able to allow or disallow some of these services for their institution. Now happy to say that these managed Apple accounts can now be used for even more developer services such as app notarization now. And so these new features will help organizations continue to go and embrace and adopt these managed Apple accounts. So if you haven't looked at managed Apple accounts recently, we might encourage you to take another look again. We're very long on this as a technology, and the utility of these solutions only keeps getting better and better. All right, so let's just take a look at one little bit of what's new with Platform SSO. And for this, I'm going to be focusing primarily on one-to-one deployments. So one primary user, probably on a laptop or something like that. I'm going to differentiate this from any kind of lab or multi-user type of environment. So we're going to be focusing on one-to-one for this. And so previously, when onboarding a device, a user may have actually needed to authenticate with their identity provider credentials as many as 3 times. Once to authenticate the device management enrollment, a second to register the Platform SSO for the first time, and then potentially a third when logging in to their managed Apple account. But now we're happy to say in macOS Tahoe, all of these events have been coalesced into a single authentication event operation, and it happens right within the setup assistant. And so let's take a look at what this might look like. So upon activation, the Mac is bootstrapped into management using automated device enrollment, and this device management service has been federated with, in this case, Microsoft's Entra ID, but it can be any identity provider out there that's supported. I just happen to be using this one as an example. And so this is going to authenticate the device management enrollment, and so the user is going to enter their UPN. And in this particular scenario, we have a very high security bar where you must use a security key to register into Entra ID. And so that's what I'm showing here. This security key support was introduced in macOS Sequoia and continues. But it's not specific to, we don't have to be specific to security keys. I'm just showing this here. Alternatively, or I should say optionally, this security key could also be required to have a PIN to be able to unlock the key that's in there as well. And so this works with any FIDO2 compliant keys, and it also works with PIV compliant smart cards as well. If you don't want to incur the cost of security keys, maybe that's a bar higher than that's needed, you can also use authenticator apps. This is just a web view. So whatever your identity provider and your institution requires can be put in here. I'm just illustrating FIDO2 keys, and authenticator apps are great passwordless solutions so that no shared secrets are flying over the wire in that particular case. So once this has been authorized, then there's a new Platform SSO pane that appears in the Setup Assistant, and so this is going to prompt the user to register. And in macOS Tahoe, the Platform SSO can now use the token that had been acquired by that previous authentication to be able to perform the registration automatically, transparently to the end user. So they don't have to be prompted to enter their credentials again. And optionally, if we're fully adopting our managed Apple accounts, that same token then can be used to log that user into their managed Apple account as well. And so when we're going through this model, we're then going to use a local account that the user is going to use to get access to the Mac. And because we're using this in a passwordless flow, this is the only secret that the user is ever going to need to type in to get access to their system. And so you can refer to this as like a device unlock pin or phrase that the user is going to be used to unlock this device. And because the end result is going to be, the user is going to wake their device from sleep, they're going to touch ID in, and then they're going to use asymmetric keys from Platform SSO to authenticate to all the identity provider backed resources automatically, transparently, nothing to type in, nothing that can be stolen or phished. And they're going to use client certificate identities for any of the on-premises type of environment that you'd have there as well. That includes your 802.NX, remote access through VPN, Kerberos, et cetera. So then the user lands on the desktop, and again, they're going to be transparently authenticated to all those resources. You may have seen some of the demonstrations that were done yesterday as part of the session in this room. And of course, they can go and check the status within the System Settings app as well. There are some new features added to Platform SSO that I'll indicate here, but won't go into more detail. If you want more information on this, please attend yesterday's session. And now I'm going to hand it back to Matt.
We've got to do a quick one. You can probably stay up here for this. So just going to really quickly say, touching on a couple things. So really proud of the team that we pulled together, same-day support for our Platform SSO. We did all of our work on the Jamf Pro side to be able to support simplified setup, authenticated guest mode, and tap to login from Mac. That is all stuff you can configure in Jamf Pro today. Now, identity provider support for it is coming soon. So we put together a page for you, jamf.it/PSSO. Bookmark that. Keep it in your bookmarks. Come back to it. We're going to be updating that page with guides about feature support, installation steps, wizards, all the things to help you embrace PSSO as quickly as possible. I'm going to run through this with privilege escalation. Running least privilege, very important. Part of what we have as part of our platform with Connect is the ability to deploy with Platform SSO, deploy users as standard, but then be able to allow those users to seamlessly elevate to admin when they need to, providing telemetry to the SIM when those events happen, but also being able to gate that privilege escalation through an identity authentication event, which could be using Platform Single Sign-On with a fingerprint authorization to do that. Shared signals, I mentioned it a second ago. We are a shared signal transmitter. We are able to send events when they happen. If we detect a vulnerable operating system or some form of malware, we can emit that as an open signal using SSF. Okta is a receiver. They can then set policy on their side where you could invalidate access tokens, logging you out of everything on that side in real time. So this is this real response, and Okta is not the only one. There's a rich ecosystem forming around this open standard, so it's very exciting to see how Jamf can fit in to those ecosystems. Dan, take us home.
All right, yeah, I'm just going to summarize. This is where I told you what I just told you. All right, so just in summary, what we think works really well is, again, prioritize software updates should be really at the top of your list. Use device management to reduce the attack surface to that which makes sense based on your threat model and use case. Really understand what you get built in for free, the protections you get from XProtect and Gatekeeper, and then if there's anything else left over, some of those more sophisticated attacks, you can use your EDR tools for something like that. Also use phishing-resistant credentials like things like Platform SSO and User Secure Enclave Key Mode and client certificate identities for authentication. Here's some just resources that you might want to check out. There's an IDC white paper on the importance of securing endpoints from attack, available at that URL there. Of course, check out our Apple platform security guides, an actual encyclopedia of how all this stuff is implemented with lots of detail written by our software engineering group. And of course, the Apple platform deployment reference. There's lots of different great sessions here at JNUC, so please check some of these out as well. And thank you again for spending your time here with us again this afternoon. Thank you.